Moving to the types of redox reaction, we have four types of redox reaction, that is combination reaction, decomposition reaction, displacement reaction and disproportionation reaction. So first two we have seen. Moving to the third reaction, that is displacement reaction. So what is displacement reaction? In displacement reaction, ion or atom is replaced by other ion or an atom. So displacement reaction is of two types, metal displacement reaction and non-metal displacement reaction. In metal displacement reaction, more reactive metal displaces less reactive metal. We'll take this example. There is a reaction between iron and copper sulfate. So a reactive metal displaces the less reactive metal. This is the reaction called metal displacement reaction. So here what happens? Iron has displaced sulfate from copper. So iron became iron sulfate and copper sulfate became copper. So here the oxidation number of iron is 0. From 0 it became +2 and copper's oxidation state is +2. From +2 it became 0. So a highly reactive metal displaces the less reactive metal. And what about non-metal displacement reaction? It is same as that case, but you need to replace the term metal with non-metal. So here a highly reactive non-metal displaces less reactive non-metal in the salt solution. So a highly reactive non-metal will displaces less reactive non-metal in salt solution. Say for example, potassium bromide plus chloride gives potassium chloride plus bromide. So this is a reaction for non-metal reaction. So what is non-metal displacement reaction? Where highly reactive non-metal displaces less reactive non-metal. Moving to the last reaction, that is disproportionation reaction. In disproportionation reaction, an element in one oxidation state will be simultaneously oxidized and reduced. Okay, an element will be simultaneously oxidized as well as reduced in the reaction. So this is called as disproportionation reaction. Say for example, the oxidation number of that particular element is increased as well as decreased. So oxidation number is simultaneously increased as well as decreased. Say for example, hydrogen peroxide 2H2O2 gives 2 water plus oxygen. Now see the oxidation number of hydrogen, it is +1. For oxygen it is -1. So from -1 it has decreased to -2. Okay, so oxygen's oxidation state is decreased from -1 to -2. Now see in case of hydrogen where oxidation number is +1. So from +1 it is increased to 0. I'm sorry, I'm repeating this. See what is disproportionation reaction? Disproportionation reaction, an element should be oxidized simultaneously, it should be reduced. And oxidation number should be decreased as well as increased for the same element and not from the different element. I am taking the example oxygen here. I have taken the decomposition of hydrogen peroxide where H2O2 is decomposed to give you water and oxygen. Now what is the oxidation state of oxygen? The oxidation number of oxygen is -1 as we all knew. So what has happened? This oxidation number is simultaneously increased as well as decreased. How? See from -1 it is increased to 0. From -1 it is decreased to -2. This is the reaction. Okay, shall I repeat one more time? See, oxygen's oxidation number is -1. So oxygen is simultaneously increased and decreased. Say for example from -1 it has increased to 0 and from -1 it has decreased to -2. So this is called as disproportionation reaction where an element should be simultaneously oxidized and reduced. Its oxidation state should be increased as well as decreased from the same element, not from the different element. Moving to the fractional oxidation number. We know that certain element in certain compounds exist or take up fractional oxidation number. Say for example C3O2. This is carbon suboxide. C3O2 is carbon suboxide. Here the oxidation number of carbon is said to be 4 by 3. Oxidation number of carbon is 4 by 3. And how to calculate this oxidation number of carbon? See, it is nothing but average oxidation state. See, what is fractional oxidation number? Fractional oxidation number is the average of oxidation state of element in a compound. So what is fractional oxidation number? It is the average of oxidation state of element in a compound. Now how will you calculate the average oxidation state of element in a compound? It is nothing but total charge divided by total number of atoms. So it is total charge divided by total number of atoms. How will you write this carbon suboxide? I have 3 carbon and 2 oxygen. So 3 carbon and 2 oxygen can be indicated like this because carbon's valency is 4 and oxygen is 2. So I told you the fractional oxidation number should be taken into account of average oxidation state of element in a compound. What is average oxidation state? Where average oxidation state is equal to total charge by total number of atoms. So the total charge of carbon will be plus 2 and plus 2 it is 4 and the total number of carbon atom will be 3. So here the carbon's oxidation number will be 4 by 3. So we have seen types of redox reaction. We have seen oxidation and reduction in terms of oxygen, hydrogen, electron. Then we have seen the 4 types of reaction. Then we know how to solve if a particular element's oxidation state is unknown. Then we saw the rules for assigning the oxidation number. Then moving to balancing the redox reaction. How to balance the redox reaction? How to balance the redox reaction? There are 2 methods by which we can balance the redox reaction. One is oxidation number method and another one is half reaction method. What is the first method? It is oxidation number method and the second method is half reaction method. Half reaction method I will be discussing with the slide, and oxidation number method I can help you now. See, the reaction will be phosphorus plus nitric acid gives phosphoric acid, nitrogen dioxide plus water. This is the reaction. Now when you look into the oxidation number of phosphorus, it is 0. So from 0 it has gained plus 5, and when you look into nitrogen's oxidation number, it is plus 5. So plus 5 it has moved to plus 4. So this is the reaction. So phosphorus is increased from 0 to plus 5. So P is increased from 0 to plus 5. And what happens to nitrogen? Nitrogen is reduced from plus 5 to plus 4. Nitrogen is reduced from plus 5 to plus 4. So what I am going to do now, I am going to multiply phosphorus with 1 and nitric acid by 5. Because I told you your phosphorus is increased from 0 to 5 and my nitric acid is decreased from 5 to 4. So I am going to multiply the reaction. Actually the multiplication, nitric acid should be multiplied by 5 and phosphorus by 1. So if I multiply this, see, some of the balancing of reaction will be done by trial and error method. So I have multiplied P with 1 and I have multiplied nitric acid with 5. Then obviously the right hand side of the reaction will become phosphoric acid plus 5 nitrogen dioxide plus water. Now if I count the number of hydrogen atom, here 3 and here 2, 3 plus 2, 5 is there. Now looking to the left hand side, you have 5 hydrogen. So hydrogen is balanced. Now moving to phosphorus, I have 1 phosphorus here. In the left hand side, I have 1 phosphorus. So this is also balanced. Now moving to oxygen, I have 4 here. I have 10 here. 5 2s are 10. Here 1, 11. 11 plus 4, 15. So oxygen is 15 here. When you look into the left hand side, 5 3s are 15. So oxygen is also balanced. Now how many nitrogen is there? 5 nitrogen is there. Here also 5 nitrogen. So your left hand side is balanced with the right hand side. So many of the reactions should be balanced by trial and error method. I need to look into the oxidation number of the particular element. First step will be identification of species which is oxidized and reduced. Then by what factor they have oxidized, by what factor they have reduced. So here from 5 to 4 the reduction is by 1 factor. From 0 to 5 the reduction is by 5 factor, correct? So I have just cross multiplied, because for P it is reduced to 5, correct? For nitrogen it is for P it is increased to 5. For nitrogen there is an increase in 1. This is the correct factor, right? Because phosphorus is increased from 0 to 5 and nitrogen there is from 5 it has decreased to 4, so the difference is 1. For nitrogen it is 1, for phosphorus it is 5. Now I have just cross multiplied it, that I have crossed out the figure, I have crossed out the number. So for P it is 5, for N it is 1. I have made it reverse. So for P it is 1, for nitrogen it is 5. So when I do, the left hand side will be exactly balancing with the right hand side of the reaction. This is called balancing the redox reaction by oxidation number method. So the next method will be half reaction method, which will be discussing in the form of slides. Yes children, moving to redox reaction as a basis of titration. So, redox reaction is used in the titration method to determine the strength of reductant, nothing but reducing agent, and oxidant, nothing but oxidizing agent. So, in a redox reaction, titration method is used to determine the strength of oxidant and reductant. Say for example, the titration of potassium permanganate against oxalic acid. Here, potassium permanganate is acting as an oxidant, which will be taken in the burette, and oxalic acid will be taken in the pipette. I mean, it is taken in the conical flask solution. So there is a reaction between KMNO4 and the oxalic acid, where KMNO4 is an oxidant here and oxalic acid is nothing but reductant. So I'm just summing up the role of redox reaction in titration method, where you can determine the strength of oxidant and the strength of reductant, for which we have taken potassium permanganate titration against oxalic acid, where potassium permanganate is an oxidant and oxalic acid is a reductant. Here there is no need to add an external indicator, because potassium permanganate itself is a colored solution, pink color solution, purple color. So potassium permanganate acts as a self-indicator. No need to add any external indicator. Now, how will I know the end point? The end point of titration is where your oxalate is completely oxidized to carbon dioxide and my pink color appears in the solution. Okay, I told you in the burette solution I will be taking potassium permanganate. In the conical flask I have taken oxalic acid. So my end point will be the appearance of pink color, the last inch of pink color, where your oxalate will be completely oxidized to carbon dioxide. So in otherwise I can tell you end point is nothing but where your reducing and oxidizing agents are equal in terms of mole stoichiometry. So the reactant and the product means both the reactant potassium permanganate and the oxalic acid will be consumed in equal molar stoichiometry. Then there occurs the end point, which is nothing but appearance of color. In a second type of titration reaction where dichromate is used, since dichromate is a colorless solution, I mean whenever a titration involving dichromate is used, I need to add an external indicator, that is diphenylamine. Diphenylamine is used as an indicator against titration with a dichromate solution. Okay, diphenylamine is an indicator used for the titration reaction which is involving dichromate. So what is the end point here? The end point will be the appearance of intense blue in color. So the third type of reaction where iodine is produced, then I can use a starch as an indicator. So upon the formation of color blue, I will be knowing that iodine is produced. So this is nothing but redox reaction as a basis of titration. So how redox reaction is used in titration to determine the strength of oxidant and reductant? We have seen three examples: titration of potassium permanganate, titration of dichromate, and the reaction where iodine is produced. There starch can be used as an indicator, and the end point will be the production of blue color, will be the formation of blue color. Next, moving to redox reaction and the electrode process. Okay, next is nothing but redox reaction and the electrode process. Here I am going to use a zinc rod as an electrode. The zinc rod should be dipped in the copper sulfate solution. So what happens in redox reaction? What will happen? Zinc will be oxidized to Zn2 plus and copper will be reduced to Cu. Okay, that's why the simultaneous oxidation reduction happening in the redox reaction, where I am going to involve electrode process. for which I have taken zinc rod. Zinc rod is dipped in copper sulfate solution. So what happened? Zinc is oxidized and copper is reduced. So I can say transfer of electrons from zinc to copper has taken place, and this is an exothermic reaction. So this is about redox reaction and the electrode process, use of electrode where simultaneous oxidation and reduction is happening, and the transfer of electrons from one to other element. Now what is redox couple? Redox couple is oxidation and reduction form of a compound which is taking part in oxidation and reduction reaction is called as redox couple. I can tell from this example, Zn bar Zn2 plus is a redox couple. Cu2 plus bar Cu is a redox couple. So the oxidized and the reduced form of a particular element taking part in the oxidation and the reduction reaction is called as redox couple. And what is electrochemical cell? Dry cell is an example for electrochemical cell. A cell where chemical reaction leads to the production of electric current is called as electrochemical cell. So what is electrochemical cell? Cell where the chemical reaction results in the production of electricity, or I can say conversion of chemical energy to electrical energy, where dry cell is a typical example for electrochemical cell. So we have seen redox reaction as a basis of titration, redox reaction in terms of electrode process, and redox couple electrochemical cell. Yes. So children, we have seen about the redox couples, then we saw what is electrochemical reaction. Next is moving to Daniell cell, an important question from the chapter. So Daniell cell contains two redox couple. What is redox couple? An oxidizing and reducing form of a compound or a substance in oxidation reduction reaction is said to be your redox couple. That is oxidized and reduced form of a substance which is involved in oxidation and reduction reaction. So I have two redox couple in this reaction. One is zinc and copper. Whenever you are indicating a redox couple, the redox couple should be indicated in such a way such that the oxidized form should be indicated first, followed by the reduced form. So here zinc oxidized reduced form, copper oxidized and reduced form. So here I am going to take two beakers. In one beaker I am filling with 1 molar zinc sulfate solution, and other beaker I am filling with 1 molar copper sulfate solution. And these two solutions are connected by means of a salt bridge. What is salt bridge? Salt bridge is nothing but an U-shaped tube which contains potassium chloride or potassium nitrate solution, which is solidified by heating it with agar-agar solution, and then I am cooling it to become a jelly-like substance. I have in a zinc sulfate solution a zinc rod dipped in it, and I have in copper sulfate solution a copper rod dipped in it. So the main intention of providing the salt bridge is it provides electrical contact between two solutions without the solution themselves being mixed up. So till that I think the instrumentation is clear. I have zinc sulfate solution 1m and 1m copper sulfate solution in two beakers. I have zinc rod and copper rod, and both these are connected by means of an salt bridge, which is nothing but an U-shaped tube where I have either potassium chloride or potassium nitrate, which can be solidified by adding agar-agar, and then cooling it becomes a jelly-like consistency. So the main intention is to provide electrical contact between two solutions without the solutions themselves being mixed up. Now see, this zinc rod and copper rod are connected to a meter, and a meter is then connected to means of switch. So this is how the instrumental setup. Now in the beginning, when the current is off, that is when the switch is off, there is no current because there is no reaction happening. Now when the switch is on, then there is flow of current takes place because there is a potential difference between copper and zinc electrodes. So when switch is off, no chemical reaction, so no current flows. But when switch is on, current flows. Why? Because there is a potential difference between copper and zinc electrodes. Means from copper the electrons are moving towards, from zinc the electrons are moving towards copper. That is flow of electrons from zinc to copper, that is flow of current from anode to cathode. Okay, so when switch is on, then the current is flowing because there is a potential difference, and it is from anode to cathode because electrons are moving from zinc to copper electrode. So this is about Daniell cell. So about your oxidation electrode and a reduction electrode. What is an oxidation electrode? An electrode where oxidation happens or where oxidation occurs. Oxidation is nothing but loss of electrons. So that is called as oxidation electrode. Now among your cathode and anode, which is going to act as an oxidation electrode, your anode will be acting like an oxidation electrode. Then moving to reduction electrode, an electrode where a reduction reaction takes place. Reduction is nothing but gain of electrons, and cathode is going to act like an reduction electrode. Now I told you here, when the switch is on, there is a potential difference between copper and zinc electrode. What is potential difference? See, there is a flow of current between any 2 points whenever there is a difference in potential between two electrodes, and that can be measured by means of voltmeter. This is called as potential difference. So what is potential difference? Current flows between 2 points whenever there is a difference in potential exists between them, which can be measured by means of voltmeter. And what is standard electrode potential? What is standard electrode potential? Whenever the term standard is included, it means there is a reference electrode. Standard means all the conditions are kept optimal. Say for example, temperature, pressure, and upon measuring it, I am going to call that as standard condition. So what is standard electrode potential? Standard electrode potential is measured in terms of volts. So standard electrode potential is developed in a cell which contains two electrodes. What are the two electrodes? I have one electrode as pure metal, which is dipped in 1 molar solution of its own ion. Say for example, zinc electrode is dipped in zinc sulfate solution, and copper electrode dipped in copper sulfate solution. So in standard electrode potential, which can be measured in terms of volts, I have standard potential which is developed in a cell containing two electrodes, where one electrode is nothing but pure metal which is dipped in 1 mole solution of its ion. And what is the other electrode? The other electrode will be a normal hydrogen electrode. So this is your standard electrode potential. Moving to the last part of the chapter, that is cell potential. What is cell potential? Cell potential is difference in standard reduction potential of cathode and standard reduction potential of anode. Okay. So what is cell potential? Cell potential is defined as the difference in standard reduction potential of cathode and standard reduction potential of anode. That is, this is cell potential, which is indicated as standard reduction potential at cathode minus standard reduction potential of anode. Now I was just writing this expression in terms of reduction potential. In terms of oxidation potential, what will be the reaction? So the standard cell potential is equal to difference in standard oxidation potential at cathode minus standard oxidation potential in terms of anode. So this is with respect to standard cell potential. I mean cell potential in terms of reduction potential and oxidation potential. Now what is standard reduction potential? I was telling in terms of reduction potential and oxidation potential, right? Before I have told you what is oxidation electrode and what is reduction electrode. Now what is standard reduction potential? Potential difference is developed when a given electrode undergoes reduction. When it is in contact with ions having 1 molar concentration, which is coupled with a standard hydrogen electrode. I am repeating. What is standard reduction potential? Standard reduction potential is defined as a potential difference which is developed when a given electrode undergoes reduction. Now, when this electrode is in contact with its own ion at 1 molar concentration, coupled with a reference electrode which is nothing but standard hydrogen electrode, your standard reduction potential and standard oxidation potential are equal in magnitude, only difference is sign difference. Alright. Now what is standard oxidation potential? You can derive your own definition from reduction potential. What is standard oxidation potential? Standard oxidation potential is defined as the potential difference developed when a given electrode undergoes oxidation when it is in contact with 1 molar concentration coupled with a reference electrode, that is standard hydrogen electrode. That done? Clear? So I am repeating, what is cell potential? That is cell potential in terms of oxidation potential and reduction potential I have explained. What is oxidation potential? A potential difference developed in an electrode when it undergoes oxidation, when it is coupled with a reference electrode, that is standard hydrogen electrode. What is reduction potential? Potential difference developed in an electrode when it undergoes, if it is reduction potential, indicate reduction. If it is oxidation potential, indicate oxidation. But both will be in reference with the, both will be coupled with a reference electrode, that is standard hydrogen electrode. Done. Now what is electrochemical series? So electrochemical series is defined as series of elements which are arranged in a decreasing order of reduction potential. Here the elements should be arranged in the order of decreasing, they should be arranged in decreasing order of reduction potential. That is, the reducing power should be increasing and the oxidizing power should be decreasing. This is called as electrochemical series. Now when I was explaining about cell potential, standard reduction potential, standard oxidation potential, I was explaining that they both will be coupled with a reference electrode, that is called as standard hydrogen electrode, which is commonly called as She. What is standard hydrogen electrode? See, standard hydrogen electrode, as I have indicated, it's a reference electrode. Okay, so it has all standard conditions in it. So this is used as a reference electrode. See, its electrode potential will be 0 volts. See how you can make hydrogen electrode. A standard hydrogen electrode can be made by a piece of platinum which is coated with finely divided platinum black, where hydrogen gas is absorbed on it. So I need to take a piece of platinum, I need to coat it with finely divided platinum black, where I am going to pass your hydrogen gas, and hydrogen gas will be absorbed on it. So this is the equilibrium reaction. 2H plus 2E minus gives H2. See, pure hydrogen at 1 atmospheric pressure and the temperature 295 Kelvin is bubbled continuously to HCl over this platinum black electrode, so that equilibrium can be maintained. See, here the metal electrode is acting like an inert electrode. It is not going to react, it's acting like an inert electrode. And what is the main role of using this metal electrode? It is going to give metallic contact. It's going to provide a contact. So in oxidation potential and in reduction potential, I am using hydrogen as a reference electrode. What is hydrogen electrode and how it can be produced? That we have discussed. Thank you, children.